So, hi, myself Nazir Hussain. So, in this video, I am just giving you an idea about what are the different string instructions available in microprocessors and how these instructions are used and how do they work. So, let us have a quick look on what are the types of string instructions we have. So, we have an instruction for moving string. So here string nothing but a series of data, we can say. So here to move, normally if you want to move any data, we used to write MOV. So but if you want to move a string, you can go for a move SB. Move SB represents move string byte. It moves the string byte. So but from where to where is understand. So it is moving a byte of data from which location to which location to be understood. So all these string instructions are associated with particular registers. So similarly, if you want to move a word data, so you can write move SW. So you should not give any space here. It's a direct word, move SB, move SW. It moves a string word. Now from where to where? So where does this data transfer is happening means move SB transfers a byte data from SI memory location to DI memory location. It is a default. So it moves data from source index register to destination index memory location. Similarly, move SW moves a word data from the memory location pointed by SI into the memory location pointed by DI. So it performs a data transfer between SI and DI memory locations. So that is move. Now, so there is one more instruction called repeat. So why this repeat is used? So to perform a move operation for n number of times, so we can do that by adding this repeat instruction just as a prefix to the move SB. If you write a repeat rep and then move SB, it moves that data until the count becomes 0. So when you are about to use a repeat instruction, make sure that a count should be specified, means how many times it has to repeat the instruction. That we will also see in an example. Another instruction is there, which is CMP. CMP actually represents compare. So CMP SB represents compare string byte. It compares the string byte. So from DI. So this compare string byte or compare string works with DI register. It compares the data available in DI with the AL or AX register value. CMP SW represents compare string word. So along with that we are having scan string. So it scans a byte of string. If you write SCA SB, scan string byte, and scan string word. This instruction also works with the DI register only. So when you are using a scan string word and if you have not declared any DI register in the program, you won't get any output. And one more, couple of more. So like load string byte, LOD-SB means it will load a data into AX register from a memory. So which memory it is associated with is SI register memory. Load string byte loads a byte of data from SI memory location. Load string word loads a word data from SI memory location. Similarly, store string byte. So whatever the data loaded, if you want to store the data back, so store string byte stores the loaded data into the memory location pointed by DI. Store string word stores the word data into the memory location pointed by DI. So, and two major very important instructions here are depending on the direction flag. So if you are having a series of data and if you want to access, so the direction of accessing should be specified using these two instructions at the start of the program itself. So whatever the instruction, string instruction you use, either it might be scan, string, compare, move. So depending on this direction flag only the operation or the accessing of data happens. Now CLD represents clear direction flag. Suppose if you want to access a data, for example I am having a data of 11, 12, 13 and 14 in memory location 3000, 3001, 2, 3. So if you want to perform accessing of data either in increment fashion or in decrement fashion will be decided by the direction flag specified in the program. If you write CLD in the program, it accesses the data in an increment mode like 3000, 3001, 3002, 3003. And STD means set direction flag. If STD is declared, it accesses the data from reverse direction 3003, 3002 and so on. So all of these string instructions and their operation is mainly depending on this direction flags. So let me explain with a small program, and before going to the program you should be very clearly understanding this concept like move. All the string instructions are associated with some registers and these are performing their operation based on the direction flag. And what are the registers associated? Right. So after understanding the registers associated with all the string instructions, let us go for a small program called relocation of the string. So a string, the actual logic is a particular memory locations are having a string data in terms of bytes, and we want to relocate these bytes to a memory location which is given by the examiner or in the question. So for this example I want to transfer or relocate the string data available in 4000 series locations into 5000 locations. So for this, how the program is written, just to see. So this is the program. So as I want to go for auto increment, means first I have to move 11 and then 12, then 13, 14, 15. I have to clear the direction flag for that. And then, so what is the memory location I have taken, from where, which location to which location I want to transfer is 4000 to 5000. So I should declare this 4000 in SI and this 5000 into DI if I want to transfer the data using move SB. Now, so move SI equal to 4000, move DI 5000. How many bytes of data we want to transfer is 5. So we have given the count as 5. Now, so if I write only move SB, it moves only 1 byte of data from 4000 to 5000, that's it. But if the same data has to be repeated again, so what I have added a prefix as a repeat. So what this do, after moving 1 byte of data, it observes for the direction flag, and if the direction flag is clear, it increments the addresses of SI and DI. So in the second iteration it goes for 4001 and 5001. There it moves the second byte data, so 12 to the 5000. So and then it again repeats the same operation of moving data from SI to DI 5 number of times, and the data will be moved to the desired memory location after the count is over. So just let's see the same example in the kit. So now in this kit I have written the program in the memory location 7000. So I have declared a clear direction flag, means auto increment of the addresses. Move SI 4000, the input data which I want to move, relocate. DI, it is the destination location where I want to move my data. So count 5 bytes, and I want to repeat move SB into 03. So for moving the data we have to give inputs first. So let's go for S4000, which is allocated for moving the input data. I am providing data 11, 12, 13, 14, 15. Sorry, it has 16. Let it be this data I want to transfer. So press enter. So let us see before that what is the destination location having. S5000 is having random values. So in this memory location we want our data of, so like the data specified in 4000 memory location has to be transferred here. And see, for moving this data you can write 5 times move SB also, but to reduce the repetition of instructions we go for a repeat instruction in prefix to that move SB. So now these are the already random values available in the destination. Now just let's execute the program using G command, G space 7000, starting address of the program, enter. Now after executing this data, let us check for the whether data is relocated into the DI memory location or not. See, 11, 12, 13, 14, 15, sorry 16. So all of these data has been relocated from 4000 to 5000 series of memory locations. So it's a simple program, simple logic. And similarly, if you want to go for word data transfer, what is a small change you need to do is just change move SB to move SW. So the input should also be changed. So here it moves one word data from 4000 to 5000, means from SI to DI. So let us see the same one in the kit also. Now I am going to change a small instruction in the program. So I am just going to give, instead of move SB I will write move SW. So the program is stored. Now to give the input data in terms of word format, go for SW command, SW space 4000. Now I want to transfer 1111, 2222, 3333, 4444, 5555. I want to move these 5 words to 5000 memory location. So what is this 5000 already having is this random data is there. I want my data to be moved. So just by executing this using G command, now let us check for whether the data is relocated in a 5000 memory location or not. So press enter, 1111, 2222, 3333, and so all the words have been relocated. This is about relocation of the string and string related instructions. So thank you. Right. In addition to that string relocation program, so we are having a program called reversing a string. So let us see how this program works and what is the logic behind this using string instructions. Now if you observe this, this is the program for reversing a string. So our intention is a string data is located, this is the input string 11, 12, 13, 14, 15 of length 5, and I want this to be reversed, means I want it like 15, 14, 13, 12 and 11. In this fashion I want the data in location DI after execution of the program. So how this works, what are the instructions required related to strings, see here. So initially I have selected a memory location for giving the input data, SI equal to 2000 I have taken, and where this data to be transferred in reverse direction should be specified with a DI. So DI equal to 3000 I have taken. So from 3000 location onwards I want this data here. Now I have taken a count of 5, so which represents a 5 bytes of data. Now, so actually to reverse at the output side, so we want this last data to be updated as a first data in the destination. So for doing that, we are using a logic here. So I want to access this 2004 data initially. How to access that? So for that I have increased SI with a byte of count. Suppose 2000 is the SI value. For this I have added the count value of 2005, which is now the SI value is 2005. But where is this last date available? It is available in 2004. That's why I did here sub si comma 01. Means in this 1 will be subtracted. 2004 will be the recent, means latest value of si. Means right now the location, means the data pointed from si is 15 from 2004 after executing these two instructions. Now we are in the input data at location of last data location. Now we want this to be transferred to the destination di. So how it is done? So simply by using this direction flag and load and store. Now see, so the first direction flag is set. I have already discussed about that. If direction flag is set, it goes for auto decrement model. Means the data will be transferred or loaded and the address gets decremented. So std means auto decrement. So load sb. So load sb, it loads a byte of data from the source. What is the source value? Now 2004. Means when load sb is given, it loads 1 byte data which is 15 into it, and then observing this direction flag, it decrements the address. So after loading this data, the SA value will be 2003, followed by, now see, clear direction flag, store SB. See, load SB works with SA register, store SB works with DI register. Now whatever the data loaded, so that will be stored into DI, means the 15 will be stored in DI first location. Now this instruction, after executing store SB, it checks for direction flag again. Here it is clear direction flag. Means direction flag clear means it has to go for auto increment, means from 3000 to 3001 it has to go. Right? So with this fashion we are going to repeat the same. Means we are giving a loop here. So loop will execute the instructions available in that particular loop until the count becomes 0. So likewise, so one data will be loaded and it will be, address will be auto decremented. Then the same data will be stored using store SB, and depending on direction flag, address gets incremented. So with this simple logic, this reversing of the string happens. Now, so let us execute this program and look at it. So for typing this program, we have to select a memory location within a range of 2000 to 9000 memory location. So let us just say I am taking a 4000 memory location. In 4000 memory location, I am going to type this program. So if you see here, A so A space 4000. So in this memory location I have selected for typing the program. As you see the instructions, when move si equal to 2000 means for a string you have to definitely specify source and destination depending on the instructions you are going to use. So di 3000, it is the destination where we want to store the data in the reverse way. Cx, how many bytes of data you are going to transfer, and add si comma cx, subtract 1 from si, and std load sb, cld stosb, and to repeat the same operation of the loop, we are taking loop back. So int 03. Now for this, so I have to provide input in 2000. So how to provide? Command is s command, s space 2000, enter. So here already different various values are there. What I want is my data. So simply I can type the data and press comma for giving consecutive data. 11, 12, 13, 14, 15. After giving the inputs, press enter and reset. So now I have given the data, input data. Now I can execute this program and check the result. Before checking the result, let us check the destination also. Destination is 3000. So here various random values are there. What I expect is, I expect my input data to be reversed in these memory locations. Now just execute the program. So for executing, we use G command, G space, starting address of the program, enter. After executing this, and let us check for the destination one more time. So if you observe here, so what the data required is, so this data to be reversed as 15, 14, 13, 12 and 11. So the same data, now 3000 is having 15, 14, 13, 12, 11. So this is how reversing of the string happens. Now one more example here you can say is, so we are moving here, we are reversing a word byte data. So if you want to go for a word, a simple change you need to do is, so in this program, so wherever we have used words, means bytes, there you can change it in the form of words. For example, this load string byte can be written as load string word. Store string byte can be written as store string word. So for doing this, you have to give input also in the form of word. So how to give word? SW space 2000, enter. Here you can give word 1111, comma 2222, comma 3333, comma 4444, comma 5555. Any data you can take. So when you are accessing in terms of words, you have to change the instruction to the word format. You have to give inputs also in that form of word format. Then you can see the output in 3000 location as 5555, 4444, 3333, 2222, 1111. So in this way, reversing a string word can be done with the same logic, just changing that bytes into words at the input side as well as in the instruction side. So hope you understand. Thank you.